Hello, everyone. My name is Jigin Sundar, and this is an introduction to Concurrent for MLflow. It's an open source project that will help you build DAGs of ML projects and run them in Kubernetes. We have a slick GUI interface for defining the DAG, and you can run it effortlessly without understanding or knowing how Docker works, how containers are created, how Kubernetes operates. All you need to do is Python and some MLflow. If you look at the Concurrent website, we have a simple use case defined here. You take your Python code, wrap it up into an ML project, and you store it in Git. You can then define a DAG and run it in the Kubernetes cluster. Let's go ahead and take a look at the second half of this, which is defining a DAG and running it in the Kubernetes cluster. I'm going to show a very simple hello world example that should take just a few minutes to run. I will log into our MLflow implementation. I'm using Infant Store MLflow here, but the Concurrent for MLflow project will work with other MLflow implementations as well. In this particular MLflow interface, you can see we have a new tab, Concurrents. And if you click on that, this is the interface that we use for defining a concurrent. Let's start by hitting Create Concurrent. And I am going to use the name Hello World 4. And create concurrent. And once the concurrent is created, you can go ahead and say Create Template. I will add a node of computation to this concurrent template. Let's call it Hello World. And I have an EKS cluster and a GKE cluster defined here. I'll use the GKE cluster. Name of the cluster is Parallels Free. And the name of the namespace is Parallels NS. This is a trivial example. So 256 megs of memory is adequate in the container, as is 1/4 virtual CPU. We do not need a GPU for this purpose, and we'll use just one container for this node. Finally, I'm going to point the URL at the concurrent examples, and the subpath in the repository is Hello World. With that, let's hit Add, and I'll move to the center just for convenience sake, and I will say Save Template. Now that we have the concurrent saved, if you go back here, for example, you can see Hello World, the new concurrent that we just created. We can go ahead and hit Run Template. When we hit Run Template, it brings up the graph that you just created. You can make modifications if you want. You can click on Hello World and temporarily make modifications. These are not saved in the template. They're just used for the run that you're doing now. I will not make any changes here, but I will hit Run Template. And in just a few minutes, you will see an MLflow parent run created and a single child for that parent run. The single child, let's look at the run view. We can see the run view here. If I close the run view, then you can see DAG details and so on. Let's go to the MLflow experiments tab. You can see that there was a new experiment created for this DAG, and 19 seconds ago, we kicked off this particular run. The parent run holds information about the complete DAG, and each one of the child runs is a particular container that ran on behalf of the DAG. And what else can I show you while we wait for this run to complete? If you go look at the concurrents tab, all the concurrents that I have created will show up in this list. You can go in and you can make modifications, you can edit template, you can run template, and so on. Now let's go take a look at the child run. No artifacts have been recorded yet. The parent run has a run view. It's not complete yet, but if you look at .concurrent, there is logs directory. The bootstrap This is the container that goes out and runs in Kubernetes and creates your Docker environment and so on. That is complete. That is in progress. And you can see the logs from that. As you can see, you do not need any Docker knowledge, you do not need any Kubernetes knowledge, you don't need to dig up Kubernetes logs. You have the ability to run complex computation in a Kubernetes, one or more Kubernetes clusters, as a matter of fact, from the MLflow user interface. We also have a technique where we store the project files, Docker file, the ML project, and the hello world.py file. If you look at hello world.py, it's just a single line that prints hello world. If you look at the ML project, it specifies that hello world.py as the entry point, and you have a Docker file. Let's go back and look at the experiments tab and see if our run completed. We can go back here, and yes, it has green tick marks, so it completed. Let's look at what the log said. Run logs says hello world. You can also see what the Docker, what the Kubernetes clusters describe command gave it, just if you want to diagnose any problems with the system. Finally, let's go back up and look at the parent run. The parent run also shows you the run view, and it shows you that the run view completed successfully, which is the green, and it has all the details, including the code, the logs. Everything is preserved for your reference. That brings us to the end of this demonstration. Thank you for watching our video.